So now here we're going to look at deriving the other compound angle identities, and all in all there's 6 of them. The other compound angle identities, or formulae, can be derived from this first one, and by this first one we mean the one we've derived already, so we've got 5 more to go. Replace phi with negative phi in the above, so then we get theta take away negative phi, and the phi here is negative phi, and then we have a negative phi over here. We know that cosine is an even function, and what we mean by that is that the cosine of negative phi is always equal to the cosine of phi. Just try doing cosine of negative 45 degrees and cosine of 45 degrees. You'll see that's the case. And sine is an odd function, so the sine of negative phi is equal to negative the sine of phi. So if we apply that here, that's going to change this sign. But this one will stay the same sign. It will stay positive because cosine of negative phi is cos phi, and here we have a minus minus, so that will become a plus. And then we get cos of theta plus phi is cos theta cos phi, so that one hasn't changed. But note, to get sine theta sine phi, this one changes to a negative because of this fact just here. So that's our second one, and we've got 2 for cos now. So now we're going to look at getting them for sine. So we'll start back with the basic one that we derived in the previous lesson. And we're going to replace theta with theta minus 90 degrees in the above. So here it is. And notice that the theta is replaced here and here as well. Now I'm just rewriting that as theta take away phi, take away 90 with the theta minus phi in the bracket. And then we know that cosine of theta take away 90 degrees is sine theta. We looked at this in radians, but it's the same identity that we've used before. We also know that sine of theta plus 90 degrees is cos theta. Now it clearly follows from that one that sine of theta minus 90 would be negative cos theta. Just think about the fact that from here to here we've actually translated horizontally by pi radians, or 180 degrees. So the last 2 identities represent a phase shift of 180 degrees, going from this one to this one. So just think about cos theta being moved 180 degrees. It clearly gives you negative cos theta. So we have now sine of theta take phi, which we got from here. So it's this identity applied here, is going to be sine theta, that's the cos theta take 90, cos phi, minus, that becomes a minus because of this minus down here, cos theta sine phi. So that's the first one for sine. From here we can use the replace phi with negative phi trick to obtain sine theta plus phi is sine theta cos phi plus cos theta sine phi. So now we've got 2 identities for sine. Now there are 2 of these compound angle identities for tan, and so we can start with the sine theta plus phi one that we've had before, and the cos theta plus phi which we've had before. And then we use the tangent identity. Tan is sine over cos, so we're just putting the expansions on top and bottom here. So tan of theta plus phi, because sine over cos is tan, would be equal to this, but it'd be nice to have it in terms of tan, and there's a trick to do this. We divide the top and bottom of the right hand side by cos theta cos phi, and because we're dividing both top and bottom, we're not actually changing the expression, just the form in which it's written. So that's all of the terms divided by this. So if we look here, cos phi's will cancel. We have sine theta over cos theta, which is tan. Here, the cos thetas cancel, and we get tan phi. Here it completely cancels down to 1, and here we get tan theta tan phi. And so that's the first of the tangent ones. From here we can use the replace phi with negative phi trick and the fact that tan, like sine, is an odd function to obtain this result.